Hi viewers, this is Sri Ramlu. So please subscribe it before watching. Okay, today's topic is mutual induction, self induction and mutual induction. Okay, so what is the self induction and mutual induction? Let me explain with the diagrams also. Right, it is, I think it is a very clear to you. It is, I think it is appearing clearly to you. Yeah, first self induction. So self induction is denoted by symbol L. Okay, when a current flows in a coil, magnetic field is set up in it. Yes, so self and mutual induction mostly works on the principle of Lenz's law only. Okay, on the principle of Lenz's law. So before watching this video, please watch the Lenz's law. Okay, so already I have uploaded that video also, and the link is also provided below. So please watch that video first. Okay, if the current passing through the coil changes with time, an induced EMF is set up in the coil. Okay, when current passes, so see, it is already diagram is shown. So if it is a diagram having the coil type and the current is passing like this, then around the coil, I said you in the previous video, around the coil magnetic field will form like this, right, around the coil. And then magnetic field forming means it has to produce a north and south pole also. So which side north pole and south pole forms? Let me explain. By the Lenz's law, the direction of induced EMF is such as to oppose the change in circuit. See, it works on the Lenz's law only. Okay, so Lenz's law can oppose the current, change in current. When the current is increasing, when the current is increasing, the induced EMF is against the current. Okay, so suppose the current is increasing, then generally induced EMF is denoted by symbol E or sometime epsilon also. Then if the current in this direction it is increasing, this induced EMF works in opposite direction. See once again, when current increasing, the induced EMF is against, means opposite, against the current. Okay, against the current increasing direction like this, then induced EMF is opposite. So see the diagram, second diagram is shown. In increasing case, when the current is increasing, okay, so current is increasing, E works opposite to it. E means induced EMF. Next, okay, right, and when the current is decreasing, okay, it is in the direction of the current. When it is increasing, when current is increasing, EMF is opposite to the increasing direction. When the current is decreasing, induced EMF is also same direction. Okay, so further diagram is also shown. See, this is the diagram. In decreasing case, when the current is decreasing, right, induced EMF is also in the same direction, means that also decreases, and it opposes decreasing. Okay, it means it opposes decreasing. In the first case, it opposes the increasing. So it cannot increase. Main work of induced EMF is here. It cannot make to increase current, and it cannot make to decrease the current. So it can make to maintain the constant current. Now, so the induced EMF opposes any change of original current, any change, either increasing or decreasing. This phenomena is called as self induction. Okay, so this property of body is called self-inductance. And a self-induction, how can we calculate? Okay, the total magnetic flux phi b linked with the coil is proportional to the current of I flowing in it. Okay, so when the flux is directly proportional to the current, here generally the flux linked with the circuit is always directly proportional to the current. If the flux value is high, current also high. If the flux is low, current is also low. So here directly proportionality is there. If you remove the directly proportionality, write equal and one constant, that constant is taken as L only. So this L is called coefficient of self-induction. Okay, so phi is equals to Li. So don't forget, phi is equals to Li. Okay, now here induced EMF also produces in self-induction. How much that is? So already we know, according to second Faraday's law, we can calculate how much induced EMF forms. So according to second law of Farad. So second law of Farad is this one, E is equals to minus d phi b by dt. Okay, so just now phi b value we got this much and substitute here. Then L is constant, take outside, and this is induced EMF in self-induction coil. Similarly, mutual inductance also. Okay, see what is a mutual induction. Consider two coils placed near to each other. So here one coil, it is another coil. When a current is passed in primary coil, here two coils are there, and for those two coils the names has to give. So what are the name we have to give? So it is the first one is the primary coil and the second one is secondary coil. In the primary coil, induced EMF is epsilon 1. I told you just now, right? Induced EMF either denoted by E or epsilon. Okay, and here induced EMF is E2, and this is the flux produced by the primary coil, and these are the flux produced by the secondary coil. Here how many turns are there? That is N1. Here how many turns are there? That is N2. And the current in the first primary coil is I1 and current in the secondary coil is I2. Okay friends, so like this. And self-inductance of first coil is L1, self-inductance of the second coil is L2. Enough. This is, so please keep it in mind. Now, when a current is passed in the primary coil P, there is a change of magnetic flux linked with it, and induced EMF is set in the secondary coil. Yes. So here the primary coil is given like this. When the current passes through the primary coil, around it magnetic field will form. So this formed magnetic field can be linked with the secondary coil. Then in the secondary coil, induced EMF will be produced. Okay, and induced EMF is set in the secondary coil. This phenomena is called mutual inductance. Okay, the primary circuit produced, and here one thing, suppose the current is flowing in the secondary coil, then flux produced in the primary coil, and these flux linked with the current is flowing in the secondary coil and flux produced in the secondary coil, these flux linked with the primary coil. Then in the primary coil, what forms? Induced EMF will form. So that is why it is called mutual inductance. Mutual means in one coil, if you allow the current in the second coil, it forms. If you allow in the second coil, in the first coil it forms. So that is called mutual inductance. The primary circuit produced an induced EMF in the secondary. Similarly, a secondary circuit also induces EMF in the primary. So just now what I said. Hence the total induction through the secondary during the time the induced current lasts in its and difference between the induction due to the primary and secondary. Okay, here total induction through the secondary coil during the time. So if the time passes, so what happens? The current lasts means loses, current decreases. Okay, so that is it, this one in the secondary and primary coil also. Next, so coefficient, how can we calculate coefficient of mutual induction? Any two circuit in which there is a mutual induction are known as mutually coupled circuit. What we have to say? Any two circuits in which there is a mutual induction. Mutual induction means in one thing, if a current flows in secondary, current has to produce its own, and opposite also. Let the current I is in primary, P produces a magnetic flux pi B. In secondary, S. For two given coils situated in a fixed relative position, so positions are not changing of coils, it is observed that flux linked with the secondary is proportional to the current in the primary. Okay, how much? Suppose what is saying, current is flowing in primary, let it is a primary coil, then around it a magnetic flux formed. If increase the current, flux also increases, and it links with the secondary coil. In the secondary coil, what it can do, it can produce more EMF, isn't it? So more induced EMF. So here the current is also directly proportional to the flux here also. So that is why flux is also directly proportional to the current, and phi B can be written as is equals to Mi, where M is here coefficient of mutual induction. The induced EMF, the EMF induced in the secondary S is secondary coil S is given by, so from the Faraday's second law, this is E is equals to minus d phi B by dt, and phi B formula is this, and substitute here, M is constant, just now here it's given, and write it outside. This is the induced EMF in mutual induction. So okay friends, so don't forget watching this video till the end and subscribing also. Thank you.